These are the volcanic areas in Iceland. Here's a hotspot diagram. And this shows the plates. North American plate, Eurasian plate, microplate, Huger. Of Iceland is an active volcanic zone. Wow. 40% of Iceland is an active volcanic zone. Wow. See the red, it's a high temperature field. That's the volcanic system. Fissure swarms are the red lines. Volcanic fissures are yellow. The bedrock is near here. There's several different power plants. La zone géothermale granitique est constituée de zones à haute température contenant de la vapeur liée à l'activité volcanique et aux éclosions du magma dans le corps terrestre. Toutes les autres zones à haute température de l'Islande sont du même type. Une étude des roches de fond a révélé ce qui se trouve sous le volcan granitique et son entourage. Le sous-sol de la zone granitique est essentiellement composé de poules glaves et de palagonites, roches éruptives datant de l'ère glaciaire. À quelques kilomètres de profondeur, la roche est très chaude et plus bas se trouve du magma, probablement des réservoirs magmatiques. De temps en temps, celui-ci remonte du fond dans ces réservoirs. Magma comes up. Dans le corps terrestre. This is the temperature. You see the steam vents. There's the steam vents. La plupart des zones thermales apparaissent là où des fissures au fond rocheux permettent à l'eau chaude de remonter à la surface de la Terre. Cette eau et cette vapeur sont acides et transforment les roches en eau. Au sein de la zone à haute température de Hellisheidi, le magma se refroidissant dans la Terre dégage de la chaleur. Cold water and hot water mix. You can see the power lines taking away electricity they've generated. At the Hellisheidi geothermal power plant, this geothermal fluid is extracted from production wells and used for electricity and hot water production. Subsequently, the geothermal fluid is re-injected into the bedrock. So here's the heat source. Geothermal fluid, cold water, here's part of the plant. It has a cooling tower, water extractions for low pressure turbine unit, separated water, steam
from low pressure from turbine unit. Steam exhaust, that's what we're seeing. Steam from turbines 1 and 4, separated water. Water extractors for high pressure turbine unit. Cooling tower. See the steam. A lot of steam pipes. This is the other side of the plant.
Yes, we have been planning this for quite many years, and you can design a system quite, let's say, easily, and you can test it with relative ease in the laboratory. That's where you have everything is under controlled conditions. You have clean water.
The CO2 is dissolved in water.
And you're not dealing with matter.
When it comes in contact with the basaltic bedrock, it releases metals such as calcium, magnesium, and iron. These metals react with the dissolved CO2 and form stable carbonate minerals, which fill pores and fractures within the subsurface, storing the CO2 permanently.
It was definitely not a success story from day one.
When you are transferring cold water in freezing conditions, pipes tend to freeze and clog.
We are used to malfunctions of equipment.
When you're installing your injection system in a well down to a few hundred meters depth in a strong winds, in maneuvering pipes, it can be challenging.
If you are struck down, you need to stand up again. It gradually dawned upon us that it was actually working.
Then when we had finally overcome all of the problems, it was quite a big step for us.
And once, the science paper was out there, almost ever since then we have just been on this roller coaster. The paper was published in June in 2016.
This is basaltic drill core, retrieved from the depth of 550 meters.
All over the media.
Basalt is a perfect rock for CO2 mineral storage. Very porous.
Should contribute to the fact, I guess, heritage.
This could be an answer for many industries around the world that have access to CO2.
Oh yeah.
Just leave that out there, man.
Ah, CO2, I get it. It's good for climate change.
We're working on scaling Hellisheidi up on 3 fronts. And the three fronts we are working on is
Notice all the women scientists.
source, capture and storage, wherever we can implement our technology just at the location that's most cost effective. Where that's not possible,
The world's climate goals will not be achieved without a significant reduction in carbon dioxide, CO2. Coda Terminal will be the world's first CO2 mineral storage hub. Using the carb-fix technology, it will be permanently stored underground by dissolving it in water and injecting it deep into basaltic formations, where it's rapidly turned into stone through a natural process. The CO2 will be transported to Iceland from elsewhere in Europe, but Coda will also be able to store CO2 captured from local industries or from the atmosphere. By 2031, Coda Terminal will be able to mineralize 3 million tons of CO2 per year, more than half of Iceland's annual CO2 emissions. Wow. Carb fix turns carbon dioxide into stone. I get it.
The scientists, they approached us at the Reykavik Energy, and I thought it was a crazy idea. Everybody thought it was a crazy idea, but carb fix is actually a very simple idea. It's actually a natural process already happening. We are taking CO2, mixing it with water, and injecting it deep down into the bedrock, where it mineralizes and forms calcite, which is stored in the bedrock forever.
Yes, we have been planning this for quite many years, and you can design.
The method we developed for capturing and mineralizing CO2 and H2S is simple, economical and environmentally friendly. It involves separating CO2 and H2S from other geothermal gases in the scrubbing system. During the scrubbing, the gases, CO2 and H2S, are dissolved in water, resulting in a type of mineral water to form. This water is then injected into basaltic host formations, and this is what is happening here in this injection well, where we are currently injecting dissolved CO2 and H2S.
Before our trials, it was the consensus of scientists that the mineralization process would take centuries. Here, they were proven wrong.
The mineralization took just over 2 years, which is quite remarkable. And these minerals can then be stable for centuries or even millions of years.
The experiments at the Hellisheidi geothermal power plant were a success. The method developed can be utilized wherever carbon dioxide is emitted, in the vicinity of basaltic rock and water or sea. These conditions are widely found on our planet. We are faced with dire consequences of climate change.